Today we are doing lesson 6.7, solving absolute value inequalities. So today is very similar to yesterday's lesson, solving absolute value equation. However, we are combining that information with the ability to graph and or inequalities from earlier this chapter. So, no, remember, we've got absolute value means distance away from zero, and absolute value cannot equal a negative number. So with those pieces in mind, by the above note, what would the absolute value of x greater than 5 mean? So this means the distance away from 0 is more than 5. So what values are more than 5 away from 0? Right? So looking at a graph, at a number line, 0 to negative 5 to positive 5 and beyond. I did all my points. What values would be further than 5 away from 0? Right? For example, 10. 10 is greater than 5 away from 0, so is negative 7. So is negative 5.3, right? All those values are more than 5 away from 0. So we're just looking for the specific numbers where it starts. 5 is not more than 5 away from 0, but it's where the answer starts. So it means answers that are above positive 5 work, and answers that are below negative 5 are more than 5 away from 0. So what did I just graph there? Those are the solutions. But those also look like x is less than negative 5, or, because I drew both pieces, x greater than 5. So these greater than graphs look like the or. Greater than and or are going to go together. Okay. Next, what would x less than or equal to 3 look like or mean, right? So that means that, again, the distance from 0 is less than or equal to 3. So we're less than 3 away from 0. So if we graph our picture real quick here, right? Negative 3, 0, and 3, right? 4 would not work. 4 is not less than 3 away from 0. But 2 is, 1 is, even 0 is less than or equal to 3 away from 0. So this graph would be between negative 3 and 3 and all the points within that. Kind of looks like a little bit like a barbell. Right? All the values between negative 3 and 3 would work. Now I filled in my points because this is solid. Since that one's solid, both sides are filled in. And that graph looks very similar to negative 3 less than or equal to x less than or equal to 3. So this would be an and graph. So greater than graphs look like an or, less than look like an and. Okay, and so that's going to be a key to graphing these absolute value inequalities. Now the other parts of the equation is going to be finding the two values that we are between. So first, the absolute value inequality rules are if x is less than k, we're going to be between those two values. Between two numbers, we're going to be all the points between them. If x is greater than k, we're going to be pointing outwards. We're going to be more than k away from 0. Okay? Now, these first ones don't require extra steps to solve, but most of today's problems will. So, solve the inequality and graph the solution. The absolute value of x is greater than 3. You're going to look, and where's our greater than? Right here. Greater than meaning points out. So greater than will always be pointing out. So we just need to find the two values. And then to find the two values, we're going to use equals. Right? We're going to treat it like it's an equals. What two answers work for this? Right? We set the inside equal to the positive, and then we set the inside equal to the negative. Now I don't have any solving to do because of just x. So my two numbers are going to be negative 3 and 3. And we already know our graph's going to replicate this one up top. The only difference is we're at negative 3 and 3. So open and pointing out, and open and pointing out for both those numbers, and that is my graph. Okay. Next, the absolute value of x is less than or equal to 6. So again, these are all the points less than 6 away from 0. So we draw our graph. It's going to look like the less than one, right over here, right? So we need to find our points because we know it's going to look something like this. Our point between them. Now, pulling it out the same as last time, x equals 6. And then the other version, x is negative 6. right? Just like how we solved in the equation. Now, those are 2 points. Lower values on the left, upper one is on the right. -6 is less than 6. And then we draw our circles and fill it in. So, why are they filled in with this one? Because we have the equal to underneath, our points are filled in. Our first one wasn't because we were lacking the equals to underneath. Moving on for some solving. Here will require one-step solve. Solve the inequality and then graph the solution. So in this case, absolute value x plus 8 is less than or equal to 9. Less than is the graph that points toward each other. So again, less than, my graphs are between 2 points pointing toward each other. We're greater than over here, 2 points pointing away, kind of like those absolute values. So I already know they're pointing toward each other. I can basically 90% finish my graph. Right? Here's my graph, ready to go. I just need to find those points. Right? What point is that? What point is that? So, again, take the inside equal to the outside. X plus 8 equals 9. We're going to solve that. -8 minus 8, x equals 1. And then we need the other point. Set it equal to the negative. X plus 8 stays the same. The outside will flip. Equals -9 minus 8, and we get x equals -17. So the point is -17 and 1. And that is how you graph. Okay. As simple as that. Remember the pattern, greater than pointing away, less than pointing towards, find the 2 points. Next one, 3x greater than or equal to 18. So already, and right away, we know we're open pointing away, and then the equal to means filled in on both sides. And so then 3x equals 18, solving real quick, x is 6, divide by 3. And then 3x equals -18. Don't forget the second one. We clearly have 2 different points in our graph, so you just solve for both. We get -6, so -6 on the left, +6 on the right, and that's our graph. Moving on. 9 plus x is less than 10, x minus 5 greater than 7. Okay, take a minute to try to sketch it out before we draw it. And going less than means we're going to be pointing towards. I'm not filled in, so I have 2 values, just like that, and I'm solving. 9 plus x equals 10, and then 9 plus x equals -10. Find the 2 numbers. Notice the steps for solving are the same on both. We're subtracting 9 on the left, we're subtracting 9 on the right. X is 1, we get x is -19. So -19 and 1 are our answer. Next one, x minus 5 is greater than 7. A greater than graph for pointing away. So greater than away. And then to solve for each piece, x minus 5 is 7, plus 5, plus 5, x equals 12 is one of the points. X minus 5 equals -7, plus 5, plus 5, x equals -2. -2 is less than 12, so that'll be on the left, +12 is on the right, and that's our graph. So again, the big key of these graphing is to remember these 2 pieces back on that second slide. After that, it is simply solve for the equation values. One more set of these, and we'll move on to 2 steps. X minus 8 less than or equal to 17. Less than or equal to means we are pointing toward each other. Okay, scoot that further down here. And now I just need to find the values for those points. We already have it in graph. X minus 8 equals 17, and then one more for the negative. X minus 8 equals -17. Add 8 to both sides, x is 25. Add 8 to both sides, I owe 17, and have $8, I'm still going to owe 9. -9 is less than 25, so that will go on the left. If you want to follow that rule every time, it is possible to have a negative inside the bracket, like if we had -2x, right? It would flip which one's the lowest. So don't assume the negative is always on the left. Right side here, 3x minus 9 greater than or equal to 12. And greater than, we're pointing away, equal to, we're filled in. Pointing away, pointing away. We now solve for the critical point. 3x minus 9 equals 12, plus 9 plus 9. 3 times some number is 21, then that number is 7. And then the other side, 3x minus 9 equals negative 12. Again, these are two-step solves, so we don't just do adding or multiplying, we do both. Opposite of minus 9 is plus. Again, same step, both here and there, left and right. 3x is negative 3. Dividing negative 3 by 3, we get x is negative 1. Negative 1 is smaller than 7, so negative 1 on the left, 7 on the right, and there's our graph. One more set to do. 6x minus 3 is less than or equal to 15. Again, less than or equal to. I'm already going down to graph. Less than or equal to, pointing toward each other. And then solve for the points. 6x minus 3 is 15, and 6x minus 3 is negative 15. Adding 3 to both sides, 6x is 18, and x will be 3. And then plus 3 to both sides. By 15 and a half, 3, I'm at 12. 12 divided by 6 is 2, and we got a negative. Negative 2 is less than 3. So negative 2, 3. One last one. 4x plus 2 is less than 18. Okay, so we're pointing towards each other. Now we're not filled in here because it's not equal to. Find the 2 points. 4x plus 2 is 18. Subtract 2. X is going to be 4x equals 16, and x will equal 4. So last, 4x plus 2 equals negative 18, minus 2, and I'm going to get more negative. I owe 18 and I owe 2, and I owe 20. Divide by 4, and I get negative 5. Negative 5 is less than 4, and there's our final graph. Your homework will be page 364, 16 through 22, 30 through 35.